Hey everybody, this is Larry, Weekly Contest 261 here, 35 seconds to go. So give me some support, hit the like button, hit the subscribe button, join me on Discord. Let's talk about these contest problems, and a lot of people are there, we're just hanging out, chilling. And yeah, I don't really have much to say here. Let's get this started. I made a lot of mistake on the bi-weekly contest, so hopefully this is my redemption. Just no silly mistakes, and let's go. 5 seconds to go, the 6, 7, whatever. We're getting ready quickly, so let's go. And it's loading, which is sad. Go. Okay. Minimum moves to convert string. That is not good enough for me to know what that means, but let's see. Come on, load. Okay. Converting them to 0. Okay. Okay. Yeah, okay. N plus M dice. N of the number missing. Average value. Okay. Okay. Say what? So N is missing. M of them are here. So okay. Mean is okay. So total. So mean times. Let's see. M times N. Yeah, so the average of each one. Minus the total. No, wait. What a weird problem. Okay, so you have the average. So this is the total of everything, and then minus the total of these. Yeah, and then this is left over for N, right? And then, okay, I just print it real quick. This is 2, that's not right? So this is total is 6. So this is 6 minus total is 1, so this should be 5. Why is this 2? Average. Huh? Yeah, why is that 2? Oh wait, why? Whoops. Okay. Okay, so we have to fit n into this. Okay, now 12. How do we fit it? Let's see. Oh, okay, I got it. What's n? N could be really big. So then, okay. Okay, if leftover is less than n, then we turn this. If leftover is greater than 6 times n, also we turn this. Otherwise, then it is leftover. Yeah, it's really awkward, but leftover n. So then we have per and extra. So then we want to return per times n, and then extra we just do extra and sub I increment of 1. I think that should be okay. Good. Okay, 66322. Let's give it a submit. Did I miss any silly case? Okay, good. Okay. Each stone has a value. You're given stones I as the y. Okay. Any stone from there, the person loses if the sum of all the y's or removed stones is divisible by 3. Huh. I mean, this doesn't matter, but let's see. If there are no remaining stone, then Bob wins. Any stone from stones. The sum of the y's or so basically, okay. So so the first stone we move is a 2. That's a lot though. I was going to do something n cubed, but well, if I remove a 1, this is an awkward one. Anyone solve it yet? Nope. I think this is the first step. I don't know how to solve it. Okay. So if you remove a 0, you can remove a 0 to begin with. So, okay. What a decision choose. So Alice come to. If Alice removes a... Okay, so that starts from the beginning. Alice removes a 1, then Bob can return a 0 and a 1, and then Alice can return. Okay, let's just say it's 1 0, and then the next one will have to be a 1 or 0. So let's just try 0. The 0 can go all the way, and they kind of match, right? So then what happens if we do 1 and then 1? But then now you can do 2, so then now it goes back to 1. I don't know. These problems are always a little weird, but okay. So here they think Bob can always win. Bob can always win because if Alice chooses a 1, then Bob chooses a 0, and then you have 2. Alice moves a 1, moves a 0. So, okay, this is actually what I was saying. Don't know that I know how to solve this one. Two, 2, 1. And n is too big. But is there anything we can do? What's a safe state? I guess that's the question. Safe state is if it's at 1 or 2. But this depends on the edges as well, doesn't it? Can we look backwards? So we know that if everything is removed, this is a winning state for Bob. So then now we go up 1. What's a winning state for Alice? The winning state for Bob is this. Then if Alice has a winning state if what if this is 210, right? 210 is a losing state for Bob. What if it's 1-1? Well, 1-1 is losing. When can Alice win? Maybe that's a better question. Alice can win if... Maybe this is a dumb question. I don't know. I don't know another way where Alice can win. Alice can win if... Well, the zeros don't matter, so I think we can reduce this to n squared, but that's still too long. So what if it's 120, 110? Alice can win only if there's a path in which Bob has to choose a 3, right? So that means that if, so okay, 1-2 is a winning state for one winning start. What is another example? Even 1-2-0 is no good. So is there another weird one? Like well, if there's 2 1s and 2 2s, then you pick a 1, Bob picks a 1, Alice chooses a 2, and then Bob is forced to choose the last 2. I guess that's a winning state. If there's 3 1s and 3 2s, then you go 1 1, 2 2, well, 2 1, and then 2 so 1 1 because you're forced to choose a 1, and then 2, so keep it. You can maybe do it 2 as well. No, you have to choose a 1. So then now what happens? And now Alice is choose to force a 2, and then Bob has to choose to force a 2, in which okay. Let's say there's 4 1s and 4 2s, but okay. Because in every other case, Bob can at least just play it out. I think that's the key observation, maybe. So 1 1, 2 1, and then now Alice can choose a. Well, Alice is forced to choose a 2, and then now, okay. I think we have similar logic going the other way. Okay. So I think Alice only wins if count of 1 is equal to count of 2, and count of 0 mod 2 is 0, then return true. I don't know if this is true though. I don't know how to attack this one. True, false, false. Let's give it submit and get a wrong answer maybe, and then see what the wrong answer is. Okay. Oh. This has to be greater than 0. Otherwise. Okay, this is an edge case, I suppose. Because. Yeah, okay. If count of 1 is equal to 0 and count of 2 is equal to 0, we return false, because that means that you choose 0 and then you lose immediately as Alice. So yeah, okay. Well, that's unfortunate, but I'm gonna get another wrong answer. Okay. I don't know how to do this one. This is one of those weird ones. Okay, let's look at this answer. Why is it wrong? So this the answer should be true, so Alice can win. So I was wrong on this then. Okay. What a disaster. There are a lot of people that only 5 or 6 people got it. So, and they got 2 wrong answers. So maybe my approach isn't that well. But I think maybe this is a good insight one. So let's dig into it a little bit. So you have 2 5s, 1 1, and 3 0s. 5 2s, not 2 5s. And this is good because. Okay, so Alice has to choose either 1 or 2. So let's just say Alice chooses a 1, then the second. Oh. Yeah, I guess so. I guess the other case is because chooses a 1. Okay. If count of 1 is equal to 1 and okay, so then now here count 2 is greater than 0 and count of 0 mod 2 is wait, the 3 zeros, right? So that means that 1 2 2 2 and then 2. So then why can't. No, that's not the winning condition, is it? Okay, in this case, And then okay. I think I have this one backwards. No, that's not right either. So yeah. I think I know how to do it because everything is forced. So then okay. Right, I think that's the key trick is noticing that everything's forced. I okay. Can Alice win if she picks up 1 to begin with? Right. The 0 is a little bit weird, but I think that's fine maybe. So okay. So Alice chooses a 1 first. Then now Bob can either choose a 0 or a 1. Or just a lot of 2s. So the answer, okay, so let's say I think the 0 is making it confusing for me. Okay, so let's say Alice chooses a 2 on this one, and then and that means that Bob has to choose either 2 or 0. Let's just say he chooses 2. Then Alice chooses a 2 because he's forced to, or 0, but the 0 doesn't really, okay, let's just say 0 for now. And then Bob can choose a 0, and then Alice chooses a 2, and then Bob chooses a 1, and then now 2, and then Alice just loses, so there must be a better way. So it chooses 2, 0, 0, and then now Alice chooses, Bob is forced to choose a 0, and now 0s are done, so then now Bob has 2, 1, yeah, so this is 5, but that means that, yeah, okay, so that means that Alice has to choose a 1, Bob has to choose 0, and then now no choice for Bob or Alice, and Alice chooses a 2, so loses, right? So that doesn't make sense. How does Alice win this one? I actually don't know how Alice win this one. Can start with 0, so it starts with 1. So 1, but then that means that Bob has to choose a 0, and that means that Alice has to choose a 0. So Alice would have to at least hit a 2. So okay, so that means Alice has to choose a 2. Bob has to choose a 0. Alice has to choose. Oh, I guess Alice can choose a 2. But then now Bob can choose a 1. Or just 0. And then now there's 4. So Alice is forced to choose a 1. Bob doesn't even care because now it's 5. So then it'll never. I don't get it. How does Alice win on this one? Did I miss something? Okay, so we start at. I think this is just Nim's game too. I think I'm just messing it up a little bit.
Now, because the 2 doesn't cancel the 2 out on this one, right? So then that means that you have so it's not quite that. I don't know how to do this one, but apparently people know how to do cube 4 quicker. A lot of people know how to do this one now, so maybe I'm wrong, but I don't know how to do it. I don't even know how you get the right answer on this one, so There's 5 2s. So you remove a 1. I don't get how Alice's win. So 2. Forced to put a player 0. And then now Alice could choose a player 2. 1. 5. Oh, I was wrong about that one. Because 5 and a 9. Okay. I forgot that 9 is a multiple of 3. That's just awkward. Okay. So now what is 2 and then 1? Well, you can play 1, so it's 2. And then now you play 1. You can't play 1 either, so now you play 0. So then now play 0. And then now you play 2. This is 4, this is 5. And then now you have to play up to 9. Okay. I can see why Alice wins this one. I don't know how to prove that though. These are the 2 paths that Alice can take and everything else is forced. Yeah, I don't know that this is quite right per se. I mean, the decision is interesting. I don't know how to force the decision, but maybe everything is forced. Let's see. Alright, Alice plays a 1, so let's just say 1. Yeah. So then now is that though? It's not really forcing that way. Because then now you have 2 and then 2, which is the one move that I haven't thought about. Now it goes to 4, which is 1, I guess. And then because of here, then you're forced to pick a Z, or you can pick a 1, I guess. There's 2, so then now you have to figure out 2 anyway. So that means that this is still 1. And then now you're picking a 0, 0, 0, and then 2. I don't know. There's a weird problem. I feel like I'm missing something obvious on this one. So, okay. This is state 2, this is state 2, this is state 1. I don't know if this is right, but we'll see. Yeah, okay. Okay, so then now, for example, we just do and then now Bob goes, right? Bob is forced to go okay. Then we break count of t minus 1. Right. Okay. So then if all else fails, so if not found, true. Okay, let's just see. If turn goes to 1, that means that is Bob's. No, it was 0. I think it's minus 1, but because we take the first turn here, but if it's 0, that means that it was Bob's turn. So then we return true for Alice winning, otherwise we return false. Okay. Go 1 or go 2, maybe that's probably good enough. Oh, no. Why did I get rid of the things? Okay, but this is weird because why did I get rid of the things? I clicked on use example case by accident. Oh, I guess I have this one, and the other one is just 3 anyway, I believe. So okay. So expected true, that's good. 3 expected false, but why would I get 1 for this one? This one we want it to be false, but we turned true. Why? Tell me why. Okay, so if oh wait, okay, let's just print. Okay, so this is the one that I'm getting true on for some reason. Okay. So for x is equal to, did I mix it up? Yeah, I definitely mixed it up, because current should current plus t mod 3. Well, that made it even more wrong, so that's a little unfortunate. Because before that, this was false. Well, that's fine. Oh, I also, because this doesn't really work, that's why. Okay, let's see. Okay, I need to redo this, that's why. Okay. Okay, I think this now matches what our expectation is. So let's YOLO a little bit again, because I don't know what else to put here. Anyway. Okay, that's unfortunate, actually. So there's just 7,000. Why did I print it twice? Oh, because I put it inside. Okay, 70,000 ones. I put true, but the answer is false because. Oh, there's no 2. That's why. Silly mistake. X is equal to 0. We return. Silly mistake. You can't win because you can't use it. So okay. So that looks good again. Do I have any printing statement? No. Okay. Let's give it a submit. I actually had this intuition earlier on, but I couldn't prove it. So, oh well. Okay. So yeah, that was a waste of time, but yeah, I don't know. That was a mess. Okay. You're given a string s and an integer k. I mean, so I'm really behind, and there's only 9. Well, actually, a lot of people got it, so maybe that's not bad. And a lot of people didn't get to see Q3. Okay. Lexicographically smallest subsequence of s of length k. That's the letter that has appeared at least repetition times. Okay. So we have the letter y that repeats 3 times. Okay. Okay. Repetition, so 2 y's. How long did people get it? People seems to get this one pretty quickly. It really took 8 minutes and a wrong answer. Okay, so we have to do something smarter than brute force, I imagine. But because n choose k is going to be low. And that real. Yeah, and I actually had to write that. I knew that approach, but I just couldn't prove it. Okay, now I focus on this problem. Okay, so here. How do we want to think about this? What is the right approach? So here we can use sliding window, and then choose the smallest thingy. Is that reasonable? because basically the repetition of 2, we use starting window, so we have these 2, and then that means that, what does that mean, right? That means that we can take any smaller letters after it. So then this would be YECE, maybe, if we did it the sliding window approach with kind of just like lexicographically smallest. And then if we slide to the YE, then now what? Well, we take the smallest that's inside, and can we do that in a very fast way? Because basically now we want to do something like ETCODE, and then now we want to do, how do we get 2 letters out of these usage and everything in the suffix as well, though that's not noted. But basically we want to get, okay, maybe another way of putting it is taking the suffix and then, okay, I mean greedy is probably enough. No, because then it gets n squared if we do something really dumb. So you go, okay, can the second letter be A, right? Yeah, I think they let you notice that is Y, but you can actually have an A that's early on that contains it, and that would be better. So so then the question is, I think it's just character by character of, can we pick an A on the first character? The answer is yes, then yeah, I think that should be good enough. I don't know how to code it quite. We're 45 minutes, but I think that should be a good enough solution though. Okay, so then now we have, let's see. Yeah, for I, X in S, in enumerate S. Let's go at C of X dot append I, and C of course is a default dict of a list. Okay, and then now we constructed one by one. Yeah, okay. So then answer is equal to this. We return to the dot join answer, and now we go for I in range of K. Yeah, K. So one character at a time. We go, okay, can the first character be 26 or 20 be A, right? And then now and we also added maybe the last is equal to -1 or something like that. The last character use. Oh, then here we ask, okay, for a character here, actually I'm just C then. Whatever, for T in range of 26. Okay, so what is that Python ASCII lowercase thing? I actually don't. Okay. Okay, let's do that instead then. Is that the right one? String dot, okay. That should be right? Okay. Okay. So we can use A if we can use this character if there's if C of T if length of this is greater than 0. Actually, what we should do is while C of T is less than last, we should actually make this a deck C.T.pop left. If length of t is greater than 0 and C of t of 0, if we take this, what does that mean? This is the index, so we have n minus whatever characters left, maybe off by 1, but this will get us a good start. If this gives us more letters than k minus I, then I think we're good. Then yeah, then last is equal to we break and answer dot append t. Oh, I have this is mostly okay, but well, this is just also wrong, but we have to force the y times. Maybe I didn't think about that right. How do we enforce this? Dong dong dong. Dong dong. Okay. We enforce this by asking, is there still more yeast left of this letter? Okay, let's play around with that in a second. We have 45 minutes left. This is a tricky one to get right. But I don't even know how this happened, so maybe I need to fix that first. Because this should give us, oh, why is that wrong too? Did I not update last? Oh, I just didn't update it. Oh, I have a typo, so maybe that should be okay. Okay, so now this is the right answer ish. Well, what? Oh yeah, this is the right answer ish, in that this is if it doesn't have the constraints of the multiple letters. So then now we have to do a binary search on this, meaning if we take this, then how many ye's are there left? Yeah, okay. And maybe some, is it bicycle left? Well, it doesn't matter because I C of letter, if we take the last, then how many do we have left, right? So this is the index of the thing. Okay, let's put it here. L left for letters left. So this is the index which we insert. So that means that length of C of letter minus left is yeah, let's just say this is yeah, can left maybe. This is always awkward. Yeah, okay. If C left is greater than repetition, then we're good. Then we do this thing. Yeah, okay. And then here we also have to add it in a thing that I just forgot or didn't consider. Letter is equal to T, then repetition, because then we already used it once. Okay. Okay. I mean, we're somewhere. Not where we like, but somewhere. Okay. Okay, let's print this out real quick. So last left index C of letter. Okay. So in here we have, what am I printing here? So we have the last, okay.
I'm not bisecting on this. I'm bisecting on c dot t of 0. That's why. Okay, E, C, D, C, E. That looks good. Yeah, I mean, I think any debugging I do will probably take longer than 5 minutes. So I'm going to YOLO and hope for the best. Probably wrong answer though. This judging is taking so long. Okay. Yeah, I mean, I definitely miss, like I said, there might be some off by 1 here, but I think we're in a good place. We have 40 minutes left. I wish I didn't, get wrong answers, but that's fine. Okay, so A. So A's we have, or B's we have 3, 4, and 5. So we try putting an A. Let's see, what am I doing? So we try putting an A, and it looks like we have enough letters, but why? Because it thinks it has 3 repetitions left. Okay, so my condition isn't quite right. So it tries to put the second A, but we need the second A. So we need one more condition, which is that if we put this here, we don't use up a repetition. So okay, if letter is not T, then we do this thing. Because if his letter is T, then I think we're good anyway. That's where the bisect left is good. But I think here we said we have enough B's for the repetition, but we did not force to use them. How do I force to use it here? I guess if so we cannot use A the second time, because using it means that yeah, okay, let's see. If using it means that so this is the fewer than whatever part. So the left is equal to repetition, but the other thing is if k minus I, which is the number of characters left, is greater than repetition, and only if they're not the same. Okay. And letter is not T. Okay, see if that's good. Nope. So the letters left oh, because okay, so I want this to only happen if letters is not okay. That's why. So if letter is equal to T, okay, condition is equal to k minus I is greater than repetition. I forgot. Oh, I didn't do an if statement quite well. I mean, this is just way to can or this thing. Let's see. Okay. So are we Gucci here? Let's give it a submit. Probably should have took a second look at it first though, to be honest, because I think I rushed this one a little bit, but maybe. Okay, cool. Yeah, I mean, I think I like this problem. Q3 is a mess, but I think greedy is the solution. It's just that I don't know how to quite figure it out. How to explain it. The timing is a little bit tricky again. But it seems like, I mean, there's going to be a lot of penalty, so I don't know when I'm going to actually finish. Right now, though, it seems like I'm top 50, I mean, not really top 50 per se, but, you know, one of the top first 50 to finish. Maybe that's a better way to say it. That's a tricky contest, though. It definitely is a tricky contest. Yeah. Tell me why ain't nothing but copyright. So I'm not gonna say anything. Do. Okay. Sorry, I'm just catching my breath for a second. And maybe do a refresh to see how. I mean, I like Q4 is not that bad, but Q3, the thing is, the sad thing is that I actually knew, or not, I wouldn't say I knew, but I thought about, I was wondering, I was curious whether the condition was true, but I couldn't prove it. That's why I didn't do it that way. And then I kind of ran out of ideas, so I ended up doing what I did, except I have a typo, or not typo, I just coded it wrong or whatever. But yeah, okay. I guess this will take a bit of time to refresh, or maybe this is accurate. Maybe a lot of people finish Q3. I feel like Q4 wasn't that bad though. I mean, what did I get? Oh, I have a wrong answer on because I just missed one condition. But yeah, but that said, you know, I did it in 18 minutes with penalty. The top people did it in about half that time, which is about right. I mean, even the top people did it kind of like, I feel like it seems like I did it relatively I mean, not like I still did it slower, but not that slower, you know. So I'm happy with that. Like even like if I did Q3 in a reasonable time and without 3 penalties, I could have had a very good time because the top 18th, it's about where I was at, right? Like if I like 24 minutes on the last one plus a penalty, I did an 18. So if I had a better time on Q3, I would have been pretty okay. So I feel like I did okay on this one. Congrats to Save VMK again. Been very hot lately. He's been doing well. Oh, top 50, but this has a lot of penalty, right? So I don't think this will hold for. Hopefully I'm top 100 or something, but you know, I don't feel bad about it though, because Q3 is a weird one in general. Maybe like it's one of those ones where if you didn't prove it, you would get away quickly. But I couldn't prove it, so I didn't do it very quickly. But one of the first 50 to finish, but with a lot of penalties, so I understand that. But yeah, okay. Let's just say that's all I have for this one. How did you do? Hit the like button, hit the subscribe button, join me on Discord. I will see you later, and have a good one. And to good mental health. Bye bye.